MS Ramaiah University of Applied Sciences.
Hi students, let us discuss inspection of goodness of fit for a given specimen using gauging. The aim of this experiment is to inspect the goodness of fit of a given specimen using the relevant gauges. Gauging is a process of testing a component's conformance to design specifications without actually having to measure the dimensions accurately. Inspection is considered as a non-value added activity in manufacturing. Gauging helps to reduce the time needed for inspecting a component, thus reducing the proportion of non-value added time in manufacturing a component. It not only ensures the quality of the product but also saves time in the manufacturing of a product. There are various types of gauges used for inspection. They are snap gauge, plug gauge, ring gauge, thread plug gauge and thread ring gauge. Figure shows the types of gauges used in inspection. In this experiment, each of these gauges are going to be used for testing the goodness of fit of a specimen. Firstly, we are going to study the usage of snap gauges for inspecting components. Snap gauge is one of the most basic and user-friendly gauges for inspecting the linear dimensions or external diameter of a specimen without having to measure it. Snap gauges come in various shapes: horseshoe, square, semicircle, etc. Every snap gauge consists of go and no-go limits. Snap gauges are available for specific dimensions and can be used to inspect only that dimension. Figure shows the different types of snap gauges available for inspection. Each of these snap gauges will have all sets of dimensions for inspecting the goodness of fit of a specimen. Figure shows the working principle of a snap gauge. As the name suggests, a snap gauge snaps the specimen at its go limit if it is oversize. If the specimen is undersize, the snap gauge does not snap it even at its no-go limit. The experimental setup for inspecting the goodness of fit of a specimen using snap gauge consists of a snap gauge, a specimen. Here goes the procedure for inspecting the goodness of fit of a specimen using snap gauge. Select the suitable snap gauge for inspection as per the dimension to be inspected in the specimen. Place the specimen over the snap gauge in such a way that the dimension being inspected is parallel to the go and no-go limits of the gauge. Pass the specimen through the go and no-go limits as shown. If the specimen has been manufactured as per specification, it will answer the go limit but not answer the no-go limit. If the specimen does not answer the go limit, it means that the dimension being measured is oversized with respect to the design specifications. If the specimen answers the no-go limit as well, it means that the dimension being measured is undersized with respect to the design specifications. The next type of gauge is a plug gauge. A plug gauge is an instrument used to inspect the bore diameter in a specimen without actually measuring it. A plug gauge consists of a hexagonal shaft with cylindrical go and no-go limits at each of its ends. Like snap gauges, plug gauges too are available for specific dimensions and tolerances and are not interchangeable. The working principle of inspection using a plug gauge is as follows. The ends of the plug gauge are inserted into the bore of the specimen being inspected, one after the other. A specimen which is undersized with respect to design specification will not answer the go limit of the gauge. A specimen manufactured oversized with respect to design specification will answer the no-go limit of the gauge. experimental setup for inspecting the goodness of fit of a specimen using plug gauge consists of a plug gauge, a specimen with a bore. Here goes the procedure for inspecting the goodness of fit of a specimen using plug gauge. Select the suitable plug gauge for inspection as per the bore dimension to be inspected in the specimen. Hold the plug gauge parallel to the axis of the bore in the specimen and insert it into the bore for both go and no-go ends. If the specimen conforms to specifications, the bore of the specimen will answer to the go end of the gauge but not answer to no-go end. If the specimen does not answer to the go end of the plug gauge, it means that the bore dimension is undersize. If the specimen answers the no-go end of the plug gauge, it means that bore dimension is oversize. Next type of gauge is ring gauge. A ring gauge is an instrument similar to a plug gauge but inspects the diameter of a circular shaft rather than the bore diameter without actually measuring the dimension. Each dimension in a ring gauge consists of two rings, go ring and no-go ring. As seen in the previous cases, ring gauges are also available for specific dimensions and are not interchangeable. The working principle of inspection using a ring gauge is as follows. The circular shaft is inserted into the go and no-go rings of the ring gauge one after the other. A specimen which is oversized with respect to design specification will not answer the go ring of the ring gauge. A specimen manufactured undersize with respect to design specification will answer the no-go ring of the ring gauge. The experimental setup for inspecting the goodness of fit of a specimen using ring gauge consists of a ring gauge, a specimen which is a circular shaft. Here goes the procedure for inspecting the goodness of fit of a specimen using ring gauge. Select the suitable ring gauge for inspection as per the shaft diameter to be inspected. Hold the ring gauge parallel to the axis of the shaft and insert the go and no-go rings into the outer surface of the shaft. If the specimen conforms to specifications, the shaft answers the go ring but not answer the no-go ring. If the specimen does not answer the go ring, it means that the shaft is oversized with respect to design specifications. If the specimen answers the no-go ring, it means that the shaft is undersized with respect to design specifications. Next type of gauge is the thread plug gauge. A thread plug gauge is an instrument similar to a plug gauge except that it is used to inspect threaded bores instead of plain bores. The only difference between a plug gauge and thread plug gauge is that the thread plug gauge consists of threaded go and no-go limits at its ends. In addition to specific dimensions and tolerances, thread plug gauges are also available for specific thread standards like Unified, UN, British Standard Piping BSP and Metric YUM series. The working principle of inspection using a thread plug gauge is as follows. A thread plug gauge inspects the pitch diameter of a threaded bore in a specimen. The ends of the thread plug gauge are inserted into the bore of the threaded specimen being inspected one after the other. A specimen whose threaded bore is undersized with respect to design specification will not answer the go limit of the gauge. A specimen whose threaded bore has been manufactured oversized with respect to design specification will answer the no-go limit of the gauge. Experimental setup for inspecting the pitch diameter of a threaded bore using thread plug gauge consists of a thread plug gauge, a specimen with a threaded bore. Here goes the procedure for inspecting the pitch diameter of a specimen using thread plug gauge. Select the suitable gauge for inspection as per the thread specification to be inspected. Hold the gauge parallel to the axis of the threaded bore in the specimen and insert it into the bore for both go and no-go ends in rotary motion. If the thread in the specimen conforms to design specifications, the specimen will answer to the go end of the thread plug gauge but not answer to no-go end. If the thread in the specimen does not answer to the go end of the thread plug gauge, it means that the thread is undersize. If the thread in the specimen answers the no-go end of the thread plug gauge, it means that the thread is oversize. The last type of gauge which will be studied is the thread ring gauge. A thread ring gauge is an instrument similar to a ring gauge, except that it is used to inspect threaded shafts instead of plain shafts. Only difference between a ring gauge and a threaded ring gauge is that thread ring gauges consist of threaded go and no-go rings. Like thread plug gauges, thread ring gauges are also available for specific sizes like Unified, UN, British Standard Piping, BSP, and Metric Standards, EM series. Working principle of inspection using a ring gauge is as follows. A thread ring gauge inspects the pitch diameter of a threaded shaft. Threaded shaft is inserted into the go and no-go rings of the thread ring gauge, one after the other. A specimen which is oversized with respect to design specification will not answer the go ring of the thread ring gauge. A specimen manufactured undersized with respect to design specification will answer the no-go ring of the thread ring gauge. Experimental setup for inspecting the goodness of fit of a specimen using thread ring gauge consists of a thread ring gauge set, a specimen which is a circular threaded shaft. Here goes the procedure for inspecting the goodness of fit of a specimen using ring gauge. Select the suitable thread ring gauge for inspection as per the design specifications of the threaded shaft to be inspected. Hold the thread ring gauge parallel to the axis of the threaded shaft and insert the go and no-go rings onto the threaded surface of the shaft in rotary motion. If the specimen conforms to specifications, the shaft answers the go ring but not answer the no-go ring. If the specimen does not answer the go ring, it means that the threaded shaft is oversized with respect to design specifications. If the specimen answers the no-go ring, it means that the threaded shaft is undersized with respect to design specifications. Enter the observations of the experiments in the tabular column. It has to be noted that the format of the tabular column is the same for all the gauges discussed in the experiment. This experiment has its limitations. Dimensional values of the specimen cannot be determined by these gauges and hence they cannot be used in precision applications. One gauge can inspect only one specific dimension and is not applicable for any other dimension for which it is not designed. Thus, one needs to maintain multiple sets of gauges for different dimensions. This concludes the experiment, inspection of goodness of fit of a specimen using gauging.
Hello students, today we are going to conduct the experiment inspection of the goodness of fit using gauges. There are 3 different kinds of gauges we will be using in this experiment. Snap gauges, ring gauges or thread ring gauges, plug gauges or thread plug gauges. Gauging is a non-measurement inspection method where we get to know whether a specimen has been manufactured as per specification or not without getting the actual values of the measurement or the dimensions which are involved. Firstly, we will see how to use a snap gauge. The aim of this experiment is to test whether a width or any such dimension has been measured as per specification or not using snap gauges. The apparatus required for this experiment is a snap gauge. This is a snap gauge having a dimension of 50 H7. H7 is the tolerance and the basic dimension is 50 mm. Any gauge will always have 2 ends, go end and no go end. For a component to get accepted, it should pass through the go end and not pass through the no go end, which means the go end of the gauge should answer and no go end of the gauge should not answer. In the snap gauge, this portion will be known as the go end and the bottom portion will be known as the no go end, and the workpiece being tested. These are the 3 workpieces being tested for these widths. Now we will start the conduction of the experiment. Now we will be testing whether the width 50 mm has been manufactured as per specification or not in all the 3 workpieces without actually measuring it. Pick up the component in one hand and the snap gauge in the other and align them in such a way that the opening in the snap gauge coincides exactly with the width which is being measured such that they are parallel to each other. Slowly pass the component inside the snap gauge gap such that the component fits inside the snap gauge. You can see that this component is not answering go completely, which means the component has been manufactured to an oversized dimension from the specification. Now, when you pick up the second component and measure it, you can also see that the go is being completely answered in this particular case, which means the component has been measured as per specification. Similarly, in the third component, we can see that the go is not answering, which means the component has again been manufactured oversize. If any of the components would have answered the no-go side, it means that the component has been measured undersized from the specification and again it cannot be accepted. Now we will see how to use a thread ring gauge. The aim of this experiment is to test the thread diameter of a given specimen is as per the specification or not using a thread ring gauge. The apparatus required for carrying out this experiment is thread ring gauges. A thread ring gauge will always have 2 gauges in one set, the go gauge and the no-go gauge. The specification of the ring gauge will always be mentioned on the surface of the gauges. M12 means the nominal diameter of the thread is 12 mm. M stands for metric thread. 1.75 stands for the pitch of the thread. 6G stands for the tolerance, and the specimen being tested. This is the specimen which is being tested for its thread diameter using thread ring gauges. It has to be noted that whenever thread ring gauges are used, it is used only to test those components which have external threads. Now let us test the thread diameter of the specimen using thread ring gauges. Pick up the specimen. This specimen has a thread M12 into 1.75 mm. Pick up the M12 into 1.75 GO thread ring gauge. Align the threaded portion of the specimen exactly in line with the threaded portion of the thread ring gauge such that the thread of the shaft is assembled in the thread portion of the gauge. Now slowly pass the shaft inside the threaded portion of the gauge without applying much force. It should be noted that the GO gauge has to answer for the entire length of the thread in the specimen. Now it can be seen that the entire length of the thread in the specimen has been answered by the M12 into 1.75 thread ring gauge. Since the specimen has answered M12 into 1.75 GO ring gauge, it means the specimen is not oversized. Now we need to test whether the specimen is undersized using the no-go gauge. The procedure of testing whether the shaft is undersized or not is similar to how it was tested with the GO gauge. Since the pitch of the gauge is given as 1.75 threads, the component can answer the no-go gauge up to 1.75 threads, beyond which it will be termed unacceptable. Now you can see that this component is not answering the no-go gauge. Since the specimen tested answered the GO gauge and did not answer the no-go gauge, it means the component has been manufactured as per the required specification. Finally, we will see how to use a thread plug gauge. The aim of this experiment is to test whether the pitch diameter of the internal thread of a component has been manufactured as per specification or not using a thread plug gauge. The apparatus required for this experiment is a thread plug gauge. A thread plug gauge consists of two ends, GO and no-go. The plug gauge being used in this particular experiment is M8 into 1.25, where M stands for metric, 8 stands for the nominal diameter of the thread, 1.25 stands for the pitch of the thread, and 6H stands for the tolerance given for the thread, and the component which is being inspected. This is the component which is being measured in this particular experiment. It should always be noted that a thread plug gauge can only be used in cases where we need to measure the nominal diameter of a thread for an internal thread. Now let us test the diameter of the internal thread of the specimen using thread plug gauges. Firstly, pick up the specimen which is being inspected. Then pick up the thread plug gauge. Now pass the GO end of the gauge inside the threaded bore of the specimen such that the entire GO end of the gauge gets inside the threaded bore. Now you can see that the entire portion of the go end of the thread plug gauge is inside the threaded bore of the specimen, which means the thread in the specimen is not under size. Gently remove the thread plug gauge from the threaded bore and now test whether the component has been manufactured oversize or not using the no-go end. Similarly, pass the no-go end of the thread gauge inside the threaded bore. Since the pitch of the gauge has been given as 1.25 mm, it should be noted that the no-go should answer only for 1.25 threads. But as we can see, the no-go end of the gauge has been completely inserted inside the threaded bore of the specimen, which means the threaded bore has been manufactured oversize. All the three kinds of gauges which we saw in this experiment come of different sizes and ranges. It should be just ensured that the correct range of size of the gauge is used for the correct range of size of the measurements. This concludes the experiment testing the goodness of fit of a specimen using gauges.
At MSR UAS, we spark your imagination unlike any other.